In this video, we're going to look at the 3 reciprocal trig functions you must know for A-level and how to draw their graphs if you haven't committed them to memory. Alright, so the 3 functions are sec, cosec and cot, which are actually abbreviations for secant, cosecant and cotangent. Not really important for the course. Sec theta is 1 over cos theta. Cosec is 1 over sine theta, and cot is 1 over tan theta. To remember these definitions, the way to do it is look at the third letter of the reciprocal function. The third letter of sec is C, hence it's 1 over cos. The third letter of cosec is S, corresponds to 1 over sine. And the third letter of cot is T, so it corresponds to 1 over tan. That's how I tend to remember them, but up to you. To sketch the reciprocal functions, we will continually go back to these definitions. To begin with, let's try and sketch sec theta. Right, to do that, we're going to bear in mind that it is defined as 1 over cos. Alright, and we're just going to try and sketch sec between 0 and pi over 2. On this graph, you can see I've got the curve cos theta because we need to sketch 1 over the blue curve. Okay, and also one final point. Our variable on the horizontal axis is theta. Usually it's x. I've just done it with theta here. Okay, so sketching sec to begin with between 0 and pi over 2. Right. At 0, cos is 1. Sec is 1 over cos. So it's going to be 1 divided by 1. Which means sec is going to be 1 here. And then as you move along to pi over 2, cos theta gets closer and closer to 0. Which means sec, which is 1 over cos, is going to get bigger and bigger. If you can't see why, just think about it. Over here, where cos is very small, sec is 1 divided by a very small number, which is going to be close to infinity. Okay, and then at pi over 2, cos is 0. 1 divided by 0 isn't defined, it doesn't make any sense. But we get very close to, the numbers get very large close to pi over 2, so in fact this is an asymptote here. There we go. Okay, so cos gets very, very, very small, which means sec gets very, very, very large. There we go. So there's our sec curve between 0 and pi over 2. We're now going to sketch sec between pi over 2 and pi. Firstly, cos is negative in this interval, which means sec will be negative as well, because sec is going to be 1 divided by a negative number. So sec is going to be below the x-axis, and now let's try and pick up the behaviour of the curve. So very close to pi over 2, but just to the right of pi over 2, cos is very close to 0, but it's negative. If you do 1 divided by a very small negative number, you're going to be pushing down to numbers that have a large magnitude but are negative, which means you're going to be down here. And then as you get closer to pi, cos hits -1, which means sec is going to be 1 divided by -1. Sec's also going to be -1. So sec is starting over here and it's getting to -1 here. going to look like this. Next, we're going to sketch the region pi to 3 pi over 2. First of all, cos is 0 at 3 pi over 2. That means sec is 1 divided by 0. Doesn't make any sense. It's not defined. In fact, we have an asymptote for sec here. Let's draw it in. There we go. And sec is going to behave in a very similar way to what we've got here. Again, cos is negative over the interval, which means sec will be negative. And sec is starting at -1, and then over here, see, cos is approaching 0, but it's negative. If you do 1 divided by these very small numbers, we're going to get numbers down here, -1,000, minus a million, minus a billion. So we're starting at -1, and then sec is coming down here. There we go. Alright, and you can probably see the rest of the curve is going to be sketched in a similar way. There we go. Alright. From 3 pi over 2 to 2 pi, cos is positive, which means sec will be positive, and then the nature of the curve is very similar to what we have over here. And in fact, because cos is periodic, and its shape is exactly the same every 2 pi radians, the same is true for sec. So I can sketch my asymptotes wherever cos is 0. And then simply sketch my sec curve exactly the same as I've done over here. So it's going to touch the cos curve at any peaks and troughs, and then at the asymptotes it's going to blow up to infinity or down to -infinity. There we go. There we go. There we go. Lovely. Okay, and there you go. So the black curve represents sec theta. And if you sketch it, you have to make sure you get your asymptotes in there as well. The exam question will probably ask for it though. All right, underneath we've got cosec, and we're just going to use a similar approach. Underneath we've got cosec, and we're just going to use a very similar approach. Fundamental to drawing cosec is using the definition that it equals one over sine. I've got the sine curve drawn on here. Let me quickly label it. And so to draw cosec, we're just going to do 1 divided by it. You've probably realised as well that, well, you guys know because you've been working with sine and cos for a long time, the sine curve its shape is exactly the same as the cos graph. It's just translated along the x-axis. That means cosec is going to be very similar to sec, simply translated along the x-axis. So to do this, we can kind of do what we did over here for sec. First of all, wherever sine is 0, cosec will have an asymptote. So I'll put my asymptotes in. There we go. Okay, so cosec is undefined at those values because you can't do 1 divided by 0. Alright, and then to draw cosec, again, if sine is positive, cosec will be positive, and it's going to touch the peaks and troughs of the sine curve. So from 0 to pi, cosec will be that. From pi to 2 pi, we will have that. And I can do a similar thing on the left hand side. And there you go. Cosec is represented by these black curves on the graph. Finally, we're going to sketch cot theta. And to sketch it, we're going to use the definition of cot, which is it equals 1 over tan. On the board, in blue, I have a sketch of tan, so we'll use that. To begin with, we're going to sketch cot between 0 and pi over 2. Notice tan is positive for this interval. That means cot will be positive as well. Very close to 0. Tan is almost 0. Tan's a very, very, very small number. If you do 1 divided by a very small number, you get something large, which means cot will be very large down here. So cot's going to start up here. Actually, at 0, cot is undefined, so I can draw an asymptote there. There we go. So we've got an asymptote, and cot is starting somewhere up here, and then as you move from 0 to pi over 2, tan becomes extremely large, which means cot is 1 divided by a very large number. 1 divided by something very large gives you something very small. So cot is going to be down here close to 0 as theta moves across to pi over 2. Cot will look like this. And it's hitting 0 at pi over 2. Okay, yeah, it is actually a reflection of the tan graph on the line x equals pi over 4. Alright, next part of the cot curve, we're going to draw from pi over 2 to pi. Firstly, notice that that tan is negative, which means cot will be negative. Also, tan is 0 at pi. That means cot's going to be undefined here. And I can say there will be an asymptote at pi. Let's get that asymptote in there. Okay, here we go. So, just after pi over 2, tan is a negative number, which is very large in magnitude. Think minus a million, minus a billion. If you want to draw cot, you're going to have 1 divided by minus a million. 1 divided by minus a billion. So that's going to be a number very close to 0, but still negative. So cot is going to be around there. And then as you move from pi over 2 to pi, the tan curve approaches 0. Still negative, but approaches 0. So you think minus 0.1, minus 0.001. If you do 1 divided by those numbers, you get something down here at minus a million, minus a billion. So again, cot is going to mirror tan. It will look like this. And there you have it. So if you have a look at that cot curve that I've drawn from 0 to pi, it's actually, the shape of the curve is exactly like the tan curve. It's just been reflected. And the asymptotes are in slightly different places. And we can use that rule to sketch the rest of cot. Firstly, we'll put the asymptotes of cot in. Wherever tan is 0, cot will be undefined. Cot will have an asymptote. So tan is 0 here at 2 pi. tan is 0 here at minus pi, and tan is 0 here at minus 2 pi. Cool. Alright, so let's sketch from pi to 2 pi. Actually, sorry, let's sketch from pi to 3 pi over 2. Alright, tan is positive, which means cot will be positive. There we go. And then from 3 pi over 2 to 2 pi, tan is negative, which means cot will be negative. And again, we mirror the curve. Boom. Alright, coming over to negative theta. Firstly, let's do 0 to minus pi over 2. Have I finished the curve there? Yeah. Let's do 0 to minus pi over 2. Tan is negative, so cot will be negative. What have we got here? Crikey. It's a little bit wobbly. There we go. And then from minus pi over 2 to minus pi, we're looking at a positive curve. Like that. And then finally, we've got that. And that is the cot curve. The cot curve is drawn in black. I mean, it might be a little bit difficult to pick it out with all those lines on there. In the next couple of videos, we're going to look at how to prove identities and solve equations that have the reciprocal functions in them.